Let's take a look at this 4.1 to 4.3 quiz review. So we want to know about increasing, decreasing, and constant functions. So these are pretty straightforward. An increasing function or increasing is a function or a portion of a function that is moving up when going from left to right on a graph. So if there's our graph, increasing means it needs to be moving up. So it can be not real steep, it can be pretty steep, but it has to be moving up. Decreasing has to be moving down from left to right. And it can be the whole graph or it can just be a portion of it. So once again, this time maybe I'll just draw a smaller segment or something, but this would be decreasing. Constant is simply a horizontal line. It doesn't go up and it doesn't go down. So you just have a horizontal line or a portion of the graph that is a horizontal line. So if we had something like this part here would be constant. Interval notation, this is just a different way to show intervals rather than using inequalities. So interval notation, make sure, so it does look like an ordered pair, but it's just telling the start and end of an interval. And remember, parentheses mean you don't include the end point or the ending. Brackets mean you do include the end point. And for positive infinity or negative infinity, we always use parentheses because you can't include infinity. There's no end point there to include. So let's take a look at an example here where we want to use interval notation to indicate when the function is increasing, decreasing, and constant. So zoom this in a little bit. When is this function increasing? So looking left to right, we see it's increasing. I'll just color over this. So in green, it is increasing here. So when we put increasing, or the interval notation, we always use the x values. So this is increasing, and -4 is the lowest part. So it's increasing from -4 all the way up until 0. Again, we use the x values, do not use y values. Also looks like it's increasing from maybe 2.5 to 5. And if you don't have 2.5, if you had 2 or 3, I wouldn't take off for that, but it looks like it's about 2.5 to 5. So that's where it's increasing. Decreasing is moving down from left to right. So this has an arrow here, so it indicates it keeps going in that direction, but as we look left to right, that's moving down. So that is from negative infinity, which we definitely use a parenthesis there, up to -4. We can use a bracket there. It's also decreasing, moving down from left to right from 0 to 2.5. And is this thing ever constant? So constant is when it's horizontal. So it's horizontal from, in this section I'm putting in yellow, and so that starts at 5 and goes, it has an arrow there, so it goes up through infinity, and we use a parenthesis for infinity. Now, just something extra here, is this graph 1-to-1? It is not 1-to-1 because 1-to-1, what you can do is you can check, is there a horizontal line that goes through more than one point, and so it is not 1-to-1. It is a function, so there's no vertical line that goes through more than one point, but it is not 1-to-1. All right, now we get into our operations with functions. You see here in the directions, we have g of x is 2x, and h of x is x squared plus 1. And so just remember, when we do these, h plus g of x simply means we want to take h of x and add g of x. And so looking up at our functions, h of x is x squared plus 1, and we want to add g of x, which is just 2x. Now in this case, these parentheses aren't doing anything extra, so we can drop those And we usually put our answer in descending order. So we have x squared plus 2x plus 1. All right, looking at the next one, this is g minus h of x. So that's going to be g of x minus h of x. So g of x is 2x minus h of x. So the parentheses are important here because we have this negative here, and that will be distributed. So h of x is x squared plus 1. We do distribute this, and so we have 2x minus x squared minus 1. Putting that in descending order, we have negative x squared plus 2x minus 1. This next one simply means we want to multiply. So this one means h of x times g of x. So h of x from above is x squared plus 1 times g of x, which is 2x. We use the distributive property here. A lot of times we have the 2x over here, but in this case it's on the left side, so we just work with it on the right side. So we distribute. So this is 2x cubed plus 2x. And so the last one here, this is supposed to be a circle. So this is composition. This is h composed with g of x. So we remember that this is h of g of x. Well, g of x is 2x. So we want to do h of 2x, which means we put 2x in for x in our h function. So this is going to be 2x squared plus 1. We can multiply this out, so 2x, the whole thing squared is 4x squared plus 1. All right, write the inverse of the following equations. All right, we want to write the inverse. So when we write the inverse, remember what we want to do is switch or interchange x and y. And then we're going to solve for y. So they're going to progress in difficulty here. So for the first one, we're going to go ahead and we are going to switch x and y. So our inverse is x equals 3y minus 2. And now we want to solve for y. So we'll go ahead and add 2 to both sides. And we get x plus 2 equals 3y. And then we'll divide both sides by 3. So we get x plus 2 over 3 equals y. We could also, we can put y first. And this 3 is a common denominator. So this is 1/3 x plus 2/3. Both of these are correct answers. This is a function. The inverse is a function here, but that there is our inverse. Our next one, we want to switch x and y. Well, there is no y written here, but we know f of x is the same thing as y. So we can switch x and y. And so this is going to be x, so our inverse, will be x equals 4y squared minus 24. And we want to solve for y, so we add 24 to both sides. So we have x plus 24 equals 4y squared. We can divide both sides by 4. So this gives us y squared equals x plus 24 over 4. And then lastly, we take the square root of both sides. And we put plus or minus. So this is y is equal to plus or minus. Now, when you do the square root of a fraction, remember you can do the square root of the top over the square root of the bottom. Normally I would do this in one step, but I just want to show the work. And then Let's write y first and simplify this a little bit. So this is plus or minus. We can't simplify the numerator. It's just square root of x plus 24, but the square root of 4 is 2. And so there is the inverse of that. And this is a good answer. That's correct. Some might also write this as plus or minus. Dividing by 2 is the same as multiplying by a half. So 1/2 square root of x plus 24. So either one of those two is great. All right, the last one. This one gets a little trickier with the algebra, but we will go ahead and do the same thing. We're going to switch, interchange x and y. So this is going to be x equals 5y plus 3 over 4y minus 1. And so we want to solve for y. Well, we have two y's there. And so this is probably somewhat new to us. So what we want to do is let's get rid of this denominator. So we can do that by multiplying both sides by the denominator. So on the right side here, those will cancel. On the left side, we can distribute. So as I'm doing this, our goal is to get all the y's on one side. So we have 4xy minus x is equal to, and after this canceled, this just leaves us with 5y plus 3. Again, our goal is to get all the y's on one side. That's our kind of a sub goal. We have to do something after that. So get everything with y on one side and everything that does not have a y on the other side. So let's, so here's a y right here, and here's a y. So let's go ahead and get the y's on the left side. So I'll subtract 5y from both sides. And at the same time, I don't want this x over here. So again, I said it a couple times, get all the y's, all the terms with y on one side, all the terms that don't have y on the other side. So we can go ahead and add x to both sides. And so as we think through this, on the left side, we have 4xy minus 5y. These become 0. And then over here, 5y minus 5y is 0. And we have 3 plus x, or x plus 3. I usually put the variable first. I'm going to put x plus 3, but putting 3 plus x is just as good. All right, so we accomplished that sub-goal to get all the y's, all the terms with y on the left, everything that doesn't have a y on the right. And now what we do is we factor out a y. So y, this is 4x minus 5 equals x plus 3. And now you might realize what we have to do. We want to solve for y. And so we divide both sides by 4x minus 5. These cancel, and we are left with our answer. So y equals x plus 3 over 4x minus 5. And that is the inverse. That one's a little trickier. If you need to watch through that one again, just go back and watch it again. All right, and our last question, sketch the inverse of the relation. So it says relation because this one is not a function because it doesn't pass the vertical line test. The vertical line goes through more than one point. And so we want to graph the inverse. So what we learned a couple things. So let's just write them over here. This will be a reflection over the y equals x line. And so let's just sketch that in here. Y equals x line is right here. So it's going to reflect over there. And then we're going to find or choose points from the original, we're going to switch the coordinates and graph those points. All right, so here we have the point 2, -4. So we have the point 2, -4. We want to switch it, and we want the point -4, 2. -4, 2. All right, so, and another thing, this is a vertex of this sideways parabola, so this will be a vertex of a parabola. All right, let's find some other points. Looks like we have one right here. I'll put an X, so this is the point 6, -2. So we want the point -2, 6. So -2, 6. I'll put an X there so the X's match up. That's where that point came from. Let's go ahead and put a little triangle here on this point. What point is this? This is 6, -6. So switching those two, we get -6, 6. So -6, 6 is here. And maybe we see what's happening now. If you needed a couple other ones, you could maybe try to take a guess what that is. That looks like it's 4, -2.5. So we would want -2.5, 4. So -2.5, 4 would be about there. And so it looks like what we're going to do is we're going to have a parabola that's facing the other direction, which can make sense. We're switching X's and Y's. And so this used to go kind of towards infinity on the X's. The X-axis, it keeps going out and out. Well, if we switch that, it would go up toward infinity with Y values. So there is the inverse of that function. Be ready for your quiz.